January 17th is Benjamin Franklin's birthday, so today I'm going to share some fun electricity experiments with you. Hello and welcome to my channel. Today we're going to combine history by focusing on one of our founding fathers, Benjamin Franklin, with science experiments. Since the study of electricity is connected to Benjamin Franklin, all of our science experiments are going to focus on electricity. But before we get started, please don't forget to subscribe and like. The all-time best way to get your students interested in some fun electricity investigations is through a magic trick. This magic trick can be purchased online. Just show them the light and the penny, then proceed with the magic show. Have the students discuss why they think this worked, then explain to them that it was a magic trick. Let them try it out for themselves. Then let them know that today they're going to be conducting experiments that are not tricks. Their first one is creating a circuit and having a light bulb light up. Our first experiment has to do with current electricity or moving electricity. Here are the supplies that you're going to need. When I think of a current, I think of the whirlpools that I used to create in my grandmother's swimming pool. The reason for this is that they went around in a circle, they had a path that they followed, and they connected. When we are using our flashlight, the electricity has to move the same way. The power starts its journey in the negative end of the battery. Then it goes through the wires, which in our experiment is the aluminum foil, to the light bulb, then through more wires, which again is our aluminum foil, and back to the positive end of the battery. First, we are going to take 2 pieces of aluminum foil and fold them into strips in order to create our wires. Next, we are going to tape 1 strip to each side of our battery. Finally, it is time to light up our bulb. You will notice that we placed 1 strip underneath the bulb and 1 strip on the side area of the bulb. This creates your unbroken path or unbroken circuit. Now we're going to be working with an energy ball. Our goal here is to light up our ball and have it make a crazy spaceship noise. We have 2 metal strips on our energy ball. Something has to connect these 2 metal strips. Whatever we use has to be a conductor, which means that it has to allow electric energy to flow through it. Our body is a conductor. So when I touch both metal strips, the electric energy will get our energy ball going. This can be really fun if you do it with a group of friends or with a class. Have the first person touch one side of the ball, then have everyone hold hands around the circle. Then the last person in the circle touches the other metal strip. As you can see, our energy ball is still going. Now let's do some fun static electricity experiments. A lot of children like to rub a balloon on their head so they can stick it on the wall. Some of them like to rub their feet along the carpet or on a rug in order to build up that static electricity and have some electrical fun, or do some sneaky little tricks. Notice that word builds up. Static electricity is actually an electrical charge that builds up on an object. Lightning is an example of static electricity. Something to keep in mind when you are teaching is that if your object has opposite electrical charges, a positive and a negative, they will come together or attract. However, if they have the same electrical charge, say a positive and a positive, they will push away from each other. We are going to start by putting some pepper on the table. Then we are going to add the salt. Next, we are going to add static to our plastic fork. You can use a plastic spoon as well. I only had a fork, and I'm all about using what is on hand. We are rubbing this on a wool blanket in order to build up the static electricity. Now it is time to place it over our pile of salt and pepper. The pepper should begin to separate from the salt and begin to attach itself to the electrically charged plastic fork. You might see some of the salt join as well. However, pepper is lighter than salt, so it will be ahead of the game and jump first. It will also stay attached longer. This is a really fun experiment. For this one, we are charging up the balloon by rubbing it on my brother's head. As you can tell, he was overjoyed to be the only boy in the house and therefore voted to be the one to get messy hair. Anyway, back to the experiment. Now that the balloon is nice and staticky, we placed it down by the root beer can. As you can tell, the can is attracted to the balloon. We are now able to move the can around on the table. Since I forgot my bubbles, we are using a bottle that is about 10 years old. As you can tell, we are doing a fabulous job blowing them. Aha! Finally, a bubble. For this one, we again have a statically charged balloon. Our bubble is attracted to our balloon, so we are able to manipulate it and move it around. I hope you guys have a lot of fun celebrating Benjamin Franklin's birthday. Please don't forget to let me know in the comments down below if you utilize any of these activities. And if you're new here, please don't forget to subscribe and click the bell for notifications. Thank you so much for watching. And remember to be proud of your work, productive in your day, and positively joyful.